Everyone. My name is Dr. Vishal Kumar Sundar, and I'm assistant professor in Chemical Engineering Department, Parul Institute of Technology, Pai University. And today we have our guest, Ms. Prachi Prabha Pradhan, and she will deliver her lecture on Introduction to Chemical Engineering and its scope in non-ferrous industries. So, Ms. Prachi did her BTech from GIT Gunpur, Gandhi Institute of Engineering Technology, Gunpur, from Chemical Engineering Department, and MTech from NIT Rourkela. She is currently working as a junior scientist in Jawaharlal Nehru Aluminium Research Development and Design Center, Nagpur, which is under Ministry of Science, Government of India. So, Prachi, I would like to welcome you on behalf of our department, our university. Now, over to you. You can start.
Okay, so students are there?
Yeah.
Yeah, okay. Okay, thank you so much, Dr. Vishal, and all the coordinators. Thank you once again for my brief introduction. So, good afternoon, all the students of Parul University. And so today's webinar is on Introduction to Chemical Engineering and its scope in non-ferrous industries. So just let me tell about chemical engineering, what it exactly. So all we are aware of the chemical engineering, which is nothing but the engineering which is dealing with engineering and development of chemicals or processes. So the chemical engineering is also related to different disciplines where we can correlate the chemical engineering like mechanical engineering and some part in civil engineering also, and most of the chemical engineering is also related to the chemistry part. So mostly chemistry people they do on the analytical part, but chemical engineers, being a chemical engineer, they focus mostly on the development and designing of the products and manufacturing of different chemicals, and they are normally working in different sectors. So this application of engineering principles in chemical industry to convert the basic raw materials to variety of products, let it be food, let it be chemicals, and let it be for any other application. So here chemical engineers has a important role in different sectors and different plants, uh, and if you say in the research and development sector also. So mostly if we see the chemical engineering in the current scenario, so this is related to different sectors like petroleum, oil and gas industries. Most of the people who are graduated in chemical engineering, they work in petroleum, and other also people who work in fertilizer sectors. But if we think of chemical engineers in metallurgy or mining sector, there are few. So there is some gap for the chemical engineering where even many people do not have idea regarding the chemical engineering, how they are working in the mineral sectors and mining sectors as a beneficiation engineer. So for that, I'll just briefly uh, take few slides for the aluminium sector. So this is chemical engineering is not related to or not limited to only chemical factories. It is rather than it is like a bond discipline that what I have already told from mechanical engineering one end or the industrial chemistry. A chemical engineer can work in both the parts. So if we see in the current situation, in the current scenario, present scenario, so uh, chemical engineering qualification itself is suitable for metallurgical processing in the mining and metallurgical industry. That is why chemical engineers are being hired. So now let us come to the next slide. So this is all about the nucleus of discovery. So if we say this chemical engineering discipline, if we are going thoroughly, so the nucleus of discovery, it is related to physics, computer science, mathematics, chemistry, biology, civil engineering, mechanical engineering, and electrical engineering. So if we see in 1887, this George E. Davish. So he was the father of chemical engineering, and he is an engineer now. His area of specialization is chemistry. So he is from United Kingdom, Birmingham. He discovered this chemical engineering course in the late decade 1887. It is too early in 1887. So we never thought that this branch is a old branch, even not even 1900, or it is later, more than that, 1887. So this chemical engineering was the only discipline. Now if we see, there are some other disciplines like textile engineering, production engineering, electrical and electronics. So these disciplines were not there by that time, but only if we see, we still feel proud that chemical engineering was the only discipline by that time, and which was discovered in 1887 by a person from United Kingdom. So now coming to the next part, if we see about the modern chemical engineering, normally chemical engineers might be aware that all chemical engineering students will be working in a plant based on the oil sectors, based on fertilizer sectors, and chemical manufacture sectors. But there are also some other parts. It is a diversified area where chemical engineering students are working nowadays after graduations, because even we also do not think the chemical engineering students have a lot of scope in other areas, normally in the, apart from these oil sectors and fertilizer sectors and chemical manufacturing sectors. So these are some of the examples where these chemical engineering students can easily be getting some jobs, and they can utilize their knowledge after their graduations, and they can work in such kind of areas. So how these things, I'll just let you explain. uh, Basically, if we are thinking of nowadays this pollution control, if we see pollution control, so it is gaining more attention nowadays, because being a chemical engineer, which is related more or less similar to environmental engineer, so they are basically working in state pollution control board or central pollution control board, and they are improving the quality of air. They are manufacturing some devices. They are manufacturing some filters for air purification. And if we see in the pollution control, there are certain things related to waste water treatments. So this chemical engineers has a great role towards the pollution control nowadays. And all the industries, they are basically controlled by different devices, and where this chemical engineer are contributing their knowledge for developing new devices in that, for the modernization of the chemical industries. And pharmaceuticals, already we know, and pharmaceuticals, these chemical engineering people are also working. But as we see, if we are comparing in different sectors, it has very less people will be working in pharmaceuticals or or medicines industries. Pollution control has a great important, and waste treatment and recycle I have already explained. And if we come to the biocompatible materials for implants, nowadays, if we see, if it is a diversified areas, so chemical engineering, what these people are doing basically, biocompatible materials for implants means how they are implanting tissue inside the bodies, where chemical engineers are working along with the chemistry people for that is related to biotechnology, but still these people have a lot of role in this. And if we see of the biopolymers and proteins work related to biological projects also, most of the chemical engineering people are involved. And if now we'll come to the next part, where I'll be explaining about the different industries which is basically producing different kind of polymers and different kind of chemicals. There I will be explaining all those things. So this is all about the industry. If we see, this is one typical example, chemical industry. This chemical industry. So if we see the top chemical industries in India, so there are industries where most of the chemical engineers are working. So UPL, many of them might be aware of UPL, that is United Phosphorus Limited, Pidilite Industries Limited, and BASF is one of the important chemical industry, which is a multinational German-based industry, mostly used for the production of different kind of chemicals and different kind of synthetic flocculants as well. So this is a multinational company. This is very famous for the chemical engineers, where most of the chemical engineers, they are working. Even I have met a few of the chemical engineers in my organization, where they are producing different kind of flocculants or coagulants for the wastewater treatment or for any kind of settling studies. So this is one of the important industry for chemical engineering students. And if we come to the Tata Chemicals, this is also very top chemical industries in India nowadays. And for the students, if I want to say, Gujarat Heavy Chemicals Limited, Gujarat Alkalis and Chemicals Limited, Gujarat Fluorochemicals Limited. These are few industries which are in Gujarat itself. So these industries are basically producing or are related to different chemicals. If we see, so Gujarat Alkalis and Chemicals, they are normally based on the caustic soda. Uh, they have one sector in caustic soda and salt. So these are basically dealing with different kind of chemicals. And Gujarat Fluorochemicals, also similar kind of Gujarat Alkali and Chemical Limited. And if we see the other companies like Philips Carbon Black Limited, that is mostly the black product which normally we're using it for different, apart from the rubber, we are using it for any other purposes which are used for any kind of devices. And in the automobile sector, whatever steering in our car or any automobiles. So this particular Philips Carbon Black Limited, they are manufacturing different type of carbon black, which is several applications where chemical engineers are also working as a process engineer in this industry. So lastly, we might be aware of the Linde India Limited, which is the biggest gas manufacturing unit. So these are the top chemical industries where chemical engineers are working in different sectors. If we see chemicals, if we see carbon blacks, and if we see different kind of flocculants. So these people have important role in different sectors, especially in chemical industries. So what are the job opportunities in chemical engineering? Among electrical and mechanical and chemical engineering, so we never expect that chemical engineers are on an average the highest paid among all the four. So this is the recent data which I have received it. So increasing environmental awareness also, this chemical engineering has lot of opportunity in energy and sustainable industries. So one more thing apart from this other sectors, if we think of oil sectors, fertilizer sectors, chemical manufacturing sectors, nanotechnology has gained more attention for all the chemical engineering students nowadays. So all are basically related to nanotechnology. If we see for the purification, also nanotechnology is playing an important role for during the decantation process. So that is one of the future of chemical engineering, is mostly dependent on the nanotechnology also. So if we compare the other branch, other discipline students, electrical, mechanical and civil engineers, the number of chemical engineering is growing very fast nowadays. There is a high possibility that these chemical engineers will be well placed in the upcoming future, and this chemical engineering is also a most profitable branch of engineering in India as well as abroad, which I have collected in the recent news. So apart from these, if we see, petroleum and pharmaceutical sector is also booming nowadays. So this is all about the job opportunity in chemical engineering. So now coming to the next slide. So this is all about the future of chemical engineering. So it is dependent on biotechnology. As I told already, different kind of biotechnology, how it is implemented in implantation, nanotechnology, how it is used for the purification purpose, and separation technique, especially this nanotechnology, they are using it, advanced materials. And also, if we see nowadays, this 3D food printers, it has gained more attention, because even I also was not aware of it, 3D food printers. So chemical engineers are playing important role, because during the manufacturing of food, using this additive manufacturing, this 3D food printers, uh, they, for the manufacture of 3D food printers, these chemical engineers are highly demanded. So NASA has already implemented on space missions regarding this. So what these chemical engineers do in this circumstances, because in that they chemical engineers, they use some modeling techniques to manufacture different kind of food items in the industry. So this 3D food printer is very important nowadays, and this is done using different mostly additive manufacturing technology. And for students, if I say, whatever we are using, like this jams and cheese slice, so these are all based on this kind of 3D food printers. So chemical engineering people are using their techniques, using some extrusion food printers, and they are getting different kind of slice, like this cheese slice, the jam slice, when they are thinking of some particular shape. So in that cases, these people are very much essential for developing this. If we can see in the nuclear sector, so again, this is the future. As we can say now, this people, chemical engineering students, are converting this uranium into low enriched uranium. So most of the uranium these are used for different nuclear plants also. So here also chemical engineers has a great impact. Now we can see what is the difference between this chemist and chemical engineer. Even if we think of it, both are same, but chemist normally they are involved in analytical works in the laboratory, but being a chemical engineers, they have to analyze the things. They will be available for both analytical session, as well as they have to design for the whole process, for till the raw material to the manufacturing products. So very interesting part, we can see chemical engineers, even they affect the whole lifestyle of the normal human beings. We never think that chemical engineers have a great role. Whatever chemistry is happening inside our body and everything, that is everything related to more or less similar to chemistry and chemical engineering things, what reactions are happening. So chemistry create and develop original new materials and some related process. But if we see at the same time, the chemical engineering students, they are involved in the raw materials to the final end products, by giving some process flow sheet, by giving some designing to get the all end products. But if we see again, these chemical engineers, they can easily assimilate into the mining and metallurgy industry, because as we have seen, for the beneficiation of any kind of ore, if we say extraction of aluminium, extraction of uranium, extraction of gold, copper, chemical engineers are more or less involved in all those metallurgical activities for the extraction of metals out of the ore. So because of their stoichiometry, which they already know in the courses, and because of the material balances they know, so they are these chemical engineers can help the metallurgist in calculating the overall mass balances, material balances, which is going into the process and which is coming out of the process by taking certain parameters. So these chemical engineers can also work in metallurgy and mining industry in a very comfortable way. One interesting thing which I have collected recently, we can see there are where chemical and metallurgical engineers are there in South African country, in South Africa. So there are these engineers in the platinum group processing, because if we see there are non-ferrous metals. So apart from iron, because non-ferrous metals means which doesn't contain iron at all. So in these cases, if we see platinum group, which has now placed the country as the world leader, these chemical engineers have taken number one in the country as the world leader, where this platinum group processing plant is there in South Africa. So it is one of the very interesting thing where all chemical and metallurgists took number one position throughout the world in the platinum. So now coming to the next slide, how this chemical engineer works in different part. So already from the starting onwards, I already told different kind of raw materials to the final products till the end products. They are involved in the designing part, they are involved in the process flow development, they are involved in pollution control, even they are involved in the safety measurement. So they have certain roles in different areas. First, we can see designing and invention of new chemical processes, that is for chemicals, or that maybe for any other products, maybe in the food industry, maybe in the chemical industry, maybe in the fertilizer industry. And if we come to the food, agriculture, products and cosmetics, so they have also vast role in this. And mineral industries, I have already told how they are very important in mineral industries because of their role in the stoichiometry and the balances, material balances part. How much is the input and how much is the output during the process. This chemical engineering helps the other metallurgist and mineral engineer throughout the whole process. If we come to the construction, installation and supervision of plants, these people also have a great impact in designing the equipments in different industries. So they can give one plan, they can install one equipments based on their different using different parameters and different equipments requirement. But lastly, I'd say these people can also contribute in research and development activities in different sectors. So nowadays, these chemical engineers can work in even space, because Indian Space Research Organization ISRO is also recruiting a lot of chemical engineers for their space application, and in nuclear power plants and in different new atomic nuclear plants or nuclear plants. This chemical engineering people are working in R&D sector. If we see Bhava Atomic Research Center, one of the big research center which is working in related to nuclears. So here also we can say this chemical engineer has great impact in all those things. So now coming to the different non-ferrous metals. So how these all things are related in general, I told about this different kind of sectors where chemical engineers can work, but now I come to the next part where non-ferrous metal, how these chemical engineers especially work in non-ferrous metals. So non-ferrous metal means we can see there are a lot of metals which doesn't contain iron or very less iron. So non-ferrous metal mostly include our precious metals like silver, platinum, or gold. Copper, if we see it, normally most of the time copper is used as such or in the alloy form with bronze and brass. That is mostly bronze and brass mostly used for some decoration part. And if we see the silver, platinum, and gold, which is used for the jewelry, nickel and palladium, if we see, that is used in automotive parts. Nickel normally used as a catalyst for the production of ammonia, which we have already studied in chemical process technology during our engineering course. So we can know this nickel has a great impact in the production of ammonia. And if we see other metals like titanium, tin, lead, and zinc, these metals are also coming under non-ferrous metals. So zinc, most of the cases we have already seen, zinc is used for the galvanizing purpose, that is to prevent corrosion. We are doing some coating with steel to prevent the corrosion. Lastly we'll say about aluminum, how it is useful. So now after this I'll be explaining about the aluminum, how chemical engineers work in alumina refinery, and what are the different unit operations, unit processes which are even in the alumina refinery. So aluminium, if we see, there is a lot of uses of aluminium in our everyday life. Many people, they use it, they do not know whether it is made up of aluminium. First thing I'll say, when we just wake up from bed in the morning, we use toothpaste. So nobody might have thought about the toothpaste which we use normally, the toothpaste where it is kept, that is made up of plastic and some amount of aluminum. So that is our daily life. In our daily life we're using it as directly or indirectly. So that is also based on the aluminum. And if we see some of the utensils, if we are going to use, that is also based on the aluminum. And if we see medicines cover, that is also made up of aluminum, but there is very less content of aluminum in that. But most of the aluminum metals are used nowadays in power lines, in electricity, as a conductor because of its lightweight and better ductility. Nowadays people are planning to replace the copper with aluminum, but nobody is aware of this aluminum, and they are planning to replace this aluminum because of its beautiful properties and because of its lightweight and a very less melting point of around 660 degrees centigrade. So this is all about the different types of non-ferrous metals. So I'll be focusing on aluminium and different processes from the raw material starting from bauxite to alumina and then aluminium. So why we are thinking of aluminium or aluminum? So it is almost the same thing. Some people, they just pronunciate it as aluminium, and some they pronunciate it aluminum. So it depends on in which country you are residing, and will pronounce it. Aluminium is, it is the 13th element on the periodic table, and after oxygen and silicon, if we see, it is the most abundant element in the earth after these two elements. Second most used metals globally after iron. If we analyze the things globally, not only in India, so this is the second most used metals globally after iron. So which is never expected also. So this is all the beauty of aluminium. Almost everybody in the world has used a product containing aluminum at some point. Even we don't realize that we have used aluminum directly or indirectly, but we have used aluminum in any part or any point. But we never realized that we have used aluminum as a part. So as I already explained that there are when we wake up from the bed itself, if we say the aluminum, the toothpaste we are using where it is kept, that is made up of aluminum and plastic. So we never expect, that is one of the real life, every day we're using it. So now coming to the next slide, which is all about the chemical engineering processes and chemical engineers, how they work in different alumina refineries, where they are playing an important role for the production of aluminum. So chemical engineers has a great role for the production of alumina from the raw material that is nothing but the bauxite. This is a ore. So what is a ore exactly? This is a ore which is containing different kind of minerals, but we are extracting alumina out of this, and this alumina is further going to the next process where this alumina is again giving aluminium metals. So this is the bauxite ore, where we exactly say it is a lot of bauxite mines are there in state Odisha state, and but if we say there are some mines which are in Gujarat, till now it is not explored, but most of the bauxites are East Coast bauxite, which is in the Eastern Ghats, that is in Odisha and Andhra Pradesh deposits. So these bauxites are normally used for the production of alumina from bauxite, and later on using different halt-hard process, electrolysis process, this alumina is again converted to aluminium metals. So this is a very soft material, this bauxite. Bauxite consisting of different minerals, which is having a hardness of around 1 to 3 if we're measuring in a Mohs scale, and having a specific gravity of around 2 to 2.5. So if we are comparing the hardness, so it is not the softest, but not the hardest also. So it is very easy for the beneficiation point of view to get the alumina out of it. Now I'll explain how chemical engineering students or chemical engineers, they work in different alumina refinery, and how this process is related to the different unit operations, which we have already seen in the chemical engineering syllabus, or we have already studied in mass transfer, how it is useful in the production of alumina from the bauxite. So this process is nothing but Bayer's process. So it is used to recover, extract the alumina from ore such as bauxite or any other ores, but mostly we are using this process flow sheet for the production of alumina from bauxite. This process was quite old process. It was invented in 1887 by Carl Joseph Bayer. So this Carl Joseph Bayer, this person is from Austria. He's a chemist. So this process is also related to the chemical reaction engineering and different unit operations involved in this process, which we have already known in the engineering. So first, if we explain this process, what happens, how we are getting this alumina from bauxite, there are certain steps which is followed here. So initially this mines bauxite is taken, which is having a size of around 20 to 25 size. So all the students might be aware, they might have studied unit operation, I think, that is related to crossings and milling, because as we know, for the bigger size material, this crushing, grinding plays an important role for the reduction of the size of the particular minerals. So here what happens, initially the bauxite from the mines is taken, which is having a size of around 20 to 25 So further it is crossed and milled. Then what happens, this bauxite is reacting with sodium aluminate liquor. So that is one solution we are using for the extraction of alumina out of bauxite. So this is more or less, if we see, this whole process is based on the extraction process, where for the chemical engineering students can easily understand how, if a component, if a material is having two components, and we are trying to extract one component out of another by using some solution or solvent, then we can tell it as a solvent extraction if both the phases are liquid, and if both the phases are not liquid, solid liquid, we can tell it leaching. So this process is a kind of extraction process where we are getting this alumina out of this bauxite. So here these are some steps where this bauxite is going to the desiccation tank. Once it is added with sodium aluminate liquor, that is caustic solution, then it goes to the digestion. Then this is another steps. Once it is going to the digestion step, then whatever residue or byproduct which we do not require, that is the undesirable product, it goes as a red mud. Then the desirable part, again it goes to the clarification. So what happens during this process clarification, we are adding certain flocculants or coagulants. So these flocculants may be synthetic flocculants which are synthesized from the industry or man-made, or we are using it and we are separating the liquor to get the valuable product. So in our case, our valuable product is nothing but the alumina. So this valuable product we are getting, this again further goes to the precipitation, what we have studied in chemical engineering. This is quite interesting. Precipitation is nothing but the crystallization. When something is in solution form and we want to get back it to the crystal form, in that cases we are using this precipitation, and whatever liquor is generated. So here we are getting alumina as alumina in solid form, that is in crystal forms. So this is precipitation or crystallization. From the solution itself, we are getting a solid phase. So whatever again left out thing after the precipitation, the liquor which is coming from after the precipitation is again going to the evaporation. Once this evaporation is done to remove the water molecules, again it is going to the desilication circuit or digestion circuit again, and it is again added, and again we are getting this alumina as a product. So that is our main motto, to get the alumina, how to extract alumina from a given ore. So this is all about the chemical engineering part of alumina refinery, where most of the chemical engineers, they spend their time in different processes like this: desilication, digestion, clarification, precipitation, calcination, and evaporation, etc. So now coming to the bare process chemical reactions. So these are the process reactions. We can see different steps where chemical engineering people are working. So desilication, this is normally used to remove the silica content of the bauxite to get a desirable alumina content. And after desilication, we go to the digestion, which is taking place at a temperature of around 106 to 145 degrees centigrade, or 200 to 245 degrees centigrade, based on the type of bauxites is being used in different alumina refinery in the world, in India. So after digestion, we are coming to the precipitation reaction, because our main motto is to get the alumina powder. So out of the solution, we have to, from the liquid phase to solid phase, we have to get the alumina. So this is these are all reactions involved in the precipitation part. So whatever sodium aluminate liquor will be there, it will be again reacting with water molecule to give the final alumina powder, as well as the sodium hydroxide solution which we are using it. At last, calcination reactions, which is all about the removal of the moisture or water molecules which is associated with the product hydrate which we are getting it. So this calcination reactions, which is taking place at around 1100 degrees centigrade, and finally we are getting alumina. So what a chemical engineer does here, starting from the raw material bauxite beneficiation to till the end product of the alumina, this chemical engineer has a great role towards all these processes. These are nothing but our unit processes and unit operations, which already we have studied. So these are the important things in the alumina refinery. Thank you, everybody.
Thanks, Prachi. Thank you, Prachi.
Yeah,
It's
thanks.
a very wonderful session and very informative session. And I have a question regarding this. Miss, can you just tell
Yeah,
me about
yeah,
the means, like what are the research work means,
yeah.
which are going on in this area, the development of that non-ferrous materials. So can you just give some light on that?
Development of what? Can you
Means
please
like
repeat it once?
materials, like
Yeah,
in as you are working in the means, such organization.
yeah.
So I just want to know the research work, like the overview only. What kind of
Okay. Yeah. No, actually, if we see being a chemical engineer, there are a lot of things related to this Bayer process, as I have told. So, most of the plants they are approaching to our organization for some technological testing of bauxites. As I have already explained the different steps which are
yes,
involved in the Bayer process for the alumina refinery process, like to get the final end product alumina from starting bauxite. So here most of the plants they are approaching for the technological testing, means what will be the parameters used during different steps. What mainly they are asking different kind of material balances or mass balances, how much they are giving input to the particular step, and finally how much they are getting out of the different steps. If we are talking about the Dyson step or desilication steps or precipitation steps, so what are the materials requirement during the Dyson step, what are the materials requirement during the desilication steps, and how much output they're getting out of it. And recent developments related to different kind of nano related things, whatever alumina we are getting, that can be used in different sectors, like most of the things it is acting as a fire retardant, or fire retardant means we can use it for the fire prevention. So this alumina powder has a lot of medicinal uses also. So this kind of research are going on related to the alumina, and the process regarding the technological testing of the
okay.
uh, thing.
That's good. That's good. Thank you
Yeah.
so much, Prachi. Again, I'm on behalf of our department. We are very much thankful to you for your time and
Thank you
very
so much. Yeah.
thank you. Okay, Prachi.
Oh,
Okay.
yeah. Thank you, Dr. Vishal. Yeah. Thanks a lot. Yeah.